Suddenly, we realize that we might need to rewrite all the textbooks about the beginning of the universe. The James Webb Telescope is one of the greatest breakthroughs in astrophysics, and it has never failed to deliver groundbreaking discoveries. Recently, the James Webb Telescope made another groundbreaking discovery in our solar system. As the years go by, not much has changed. This familiarity made it easy to assume that everything that could make up our solar system had already been discovered. There's nothing else to see. But we couldn't be more wrong. While many of the things we find in space may be old, the universe is still expanding and creating more objects. James Webb Telescope has captured some of these new objects. Renowned theoretical physicist Michio Kaku also expressed his astonishment at these new and unknown objects passing through space. It begs the question whether the emergence of these objects is good news or not. But one thing is certain: it presents a new learning curve in the world of physics. What are these 500 new objects that have been discovered? What categories do these new celestial bodies fall into? Join us in this video as we uncover the 500 new objects detected by the James Webb Telescope as it passed through space. Recently, NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, came together to give astronomers the greatest gift they could receive: the James Webb Space Telescope, JWST. This grand gift offers them the chance to see the earliest stages of the past, and perhaps even the creation of the universe. Astronomers worldwide were taken to the edge of time. The James Webb Telescope has been hailed as the premier observatory of the next decade and one of the greatest scientific achievements of our time. The James Webb Telescope has further widened the doors of space and taken us to where everything began. James Webb was launched into space on December 25, 2021, to capture the photographs of the unknown and unravel many mysteries of the hidden universe. Equipped with state-of-the-art technology and enhanced infrared detection equipment, the telescope will enhance the unique perspective of the universe that the Hubble telescope has provided to humanity and reveal the hidden intricacies of the universe. Thanks to its low Earth orbit, the Hubble telescope has captured many images of the farthest reaches of the universe that have never been seen before. The Hubble telescope has also studied the history and evolution of many galaxies, stars, and nebulae, capturing the historical periods of our universe. Hubble also described the properties of black holes, exoplanets, and the rapid expansion of our universe. The groundbreaking achievements of the Hubble telescope won the Nobel Prize in Physics in 2011. The James Webb Telescope is the next stage of our collective adventure to explore the secrets of the universe and search for extraterrestrial life. The Hubble telescope set the pace for deep space exploration, and it is expected that the James Webb Telescope will surpass the limits of the Hubble telescope. The images from the Hubble telescope defined modern physics and opened our eyes to what lies beyond. The achievements of the Hubble telescope also ignited our existential curiosity. It sparked the fires within us, increasing our thirst for knowledge of the universe we belong to and the elements within us. Scientists with the James Webb Space Telescope announced that as soon as they began to receive data with the new and bright Deep Field Telescope, they realized that there could be galaxies much farther away than they had anticipated. So 411 is that the universe is producing galaxies much faster and earlier than many researchers thought. Just a few 100 million years after the Big Bang, there were already numerous galaxies. The James Webb Telescope allowed us to see how everything began with all the intricacies of a 3D film. Further research suggested that galaxies may have started forming only about 100 million years after the Big Bang, which occurred approximately 14 billion years ago. This timeline challenges astronomers' theories about how and when the first galaxies formed. One of the features that makes the James Webb Telescope far superior to the Hubble telescope is its size. Its size makes it stand out among space probes. James Webb has a 6.5-meter mirror made up of 18 gold-coated hexagonal segments. This allows the telescope to capture light from objects 6 times faster than the 2.4-meter lens of the Hubble telescope. But perhaps the greatest advantage of James Webb over Hubble is its high sensitivity to infrared light. The James Webb Telescope can see wavelengths from the middle to the red end of the infrared spectrum, ranging from 0.6 to 28.5 micrometers. The James Webb Telescope represents the latest generation of space telescopes. Its capabilities far exceed those of previous models. The James Webb Telescope was placed at the second Lagrange point because it was the optimal position for the telescope to perform at its best. At L2, it could explore anything beyond its primary targets. Now the James Webb Telescope also helps us keep our eyes on our solar system by sending back news about anything noteworthy within it. One of the most interesting areas of research that James Webb has captured in our solar system is the discovery of asteroids and comets. By carefully observing these celestial bodies, the James Webb Telescope provides valuable information about their compositions, structures, dynamics, and most importantly, their origins, evolutions, and potential impact risks. These observations significantly contribute to our understanding of the formation of our solar system and the smaller objects within it. Our solar system, which sheds light on the processes that shape planets and moons, operates within a balanced equilibrium, and each particle must always be in a certain position. With a telescope like James Webb, complex movements can be learned, and any disruptions to the order can be detected in time. Additionally, the James Webb Telescope also looks at the outer planets of our solar system, especially the gas giants that have fascinated us for a long time. Jupiter, Saturn, and the ice giants Uranus and Neptune are significant members of the solar system, but they are so far away that we have not been able to study them comprehensively. However, the JWST provides a glimpse into the complex dynamics that govern these massive planets by studying their atmospheres, weather patterns, and cloud formations. It also allows scientists to deepen their understanding of planetary physics and atmospheric processes in unprecedented detail and resolution, even compared to 5 years ago. The James Webb Space Telescope also investigates the mysterious forces of dark matter and dark energy in our quest to unravel the mysteries of the universe. Strange as it may sound, these two elements, dark matter and dark energy, outweigh ordinary matter and energy by far. It is believed that they contribute to the gravitational dynamics of galaxies and shape the large-scale structure of the universe. The James Webb Telescope has come a long way in scaling human understanding of our solar system by observing the gravitational lensing effects caused by dark matter and mapping its distribution to understand its role in cosmic evolution. Similarly, dark energy, a difficult force to locate, which is believed to be responsible for the accelerating expansion of the universe, has long been a topic of great interest. The James Webb Space Telescope helps in understanding dark energy by observing the most distant supernovas serving as cosmic distance markers. These observations provide important information for scientists to further develop our knowledge and understanding of the mysterious force and its role in cosmic evolution. And it doesn't end here. By conducting comprehensive research and observations on nearby galaxies, the JWST provides detailed images and spectral data that allow researchers and scientists to examine the structure, star formation rates, and evolution of galaxies. Its ability to capture infrared light enables it to penetrate cosmic dust and reveal hidden regions within galaxies, thus uncovering the mechanisms that drive their growth and the interactions between stars and gas clouds. While exploring nearby galaxies may seem challenging with so much we still don't know about our galaxy, every detail we can learn about other galaxies can reveal truths about our own. Everything in our universe works hand in hand. Some work more intricately than others. Hence, scientists are always in pursuit of capturing some of the more nuanced events. Supernovae, gamma-ray bursts, and other celestial events like them often rank at the top of the list of the most significant cosmic events to watch out for. Supernova explosions, which signal the end of a star's life, are often the most observed cosmic events. The James Webb Space Telescope plays a crucial role in capturing the spectral signatures of supernovae, allowing scientists to analyze the light emitted across a broad range of wavelengths. Researchers study the properties of the light emitted as a dying star breathes its last with a spectacular burst of toxic gamma rays and bright celestial light to gain more insight into the mechanisms underlying these catastrophic events. Scientists can now explore the true nature of the progenitor star, the dynamics of the explosion, and the subsequent distribution of elements enriching the surrounding area. Just as gamma-ray bursts raise intriguing questions about the most energetic processes in the universe, the rapid response capabilities of the James Webb Space Telescope also enable it to observe these short and intense bursts of high-energy gamma rays instantly. JWST UST can capture the radiation emitted following a burst in the electromagnetic spectrum, including infrared light. It also provides critical data to understand the nature and origins of cosmic light shows. Scientists can study the environments where gamma-ray bursts occur, such as massive star explosions or neutron-star collisions, and gain deeper insights into the physics that cause these extraordinary events. Beyond supernovae and gamma-ray bursts, the JWS focuses on transient celestial events that encompass a wide variety of energetic phenomena occurring in the universe. Some of these events include tidal disruption events. Tidal disruption events occur when a star is torn apart by the intense gravitational force of a supermassive black hole or neutron-star collision. These events often result in gravitational waves and emissions across the electromagnetic spectrum. The James Webb Space Telescope quickly responds to these events and captures their spectral signatures, providing valuable data for uncovering the underlying physical processes. It also helps scientists understand the extreme environments, energy release mechanisms, and complex interactions of matter and forces in these extraordinary events. These remarkable celestial events serve as windows into extreme cosmic environments and provide invaluable clues about current physical processes. The James Webb Telescope plays a significant role in rapidly observing and analyzing transient celestial events, contributing to unraveling many mysteries of the universe. The discovery of unknown objects in our solar system is one of the most extreme events. While it is normal for our solar system to host some visitors like Oumuamua, we have never witnessed such a surge in the number of stellar visitors before. There is no way to explain the sudden increase in the number of visitors to our solar system, and the discovery of 500 new and unidentified objects in our solar system has left many scientists and astrophysicists puzzled. These new celestial objects present an intriguing mystery to scientists. Despite many meticulous observations and analyses, these objects remain unidentified and uncategorized. Despite this setback, they represent a fascinating array of celestial entities, potentially new and unusual, or better yet, a fascinating array of celestial entities that represent the universe's wonders. The diversity and quantity of these unidentified objects present an extraordinary opportunity for scientific research and discovery, but can also pose significant threats. The discovery of 500 new objects in our solar system alone is exciting, but it also raises questions about their origins. One of the most intriguing theories about the origins of these star visitors is that they may have been ejected from black holes. Black holes are one of the most fascinating events in the universe and continue to be largely a mystery to us. Black holes are celestial entities formed by the collapse of massive stars and have such intense gravitational forces that they can disrupt nearby objects, hurling them into space. The immense power of black holes will continue to prove that they can do more than just swallow unfortunate objects that cross their paths, but also eject material like a cosmic whirlwind. We wonder if they're ejecting trapped materials within themselves. Voyager 1 recently detected an interesting anomaly on its journey. There were many signals, most of which were a bit challenging to decipher, but one of them said that Voyager had managed to detect the presence of approximately 300 unidentified objects passing through cosmic breadth. It was said that these mysterious entities emerged from the depths of interstellar space, leaving scientists worldwide incredibly puzzled. These 300 unidentified objects challenge our understanding of the universe as remnants of ancient celestial bodies and debris dragged from distant star systems. Voyager 1, located in the outer regions of our solar system, is exposed to extreme cold temperatures reaching -202 degrees Fahrenheit. Such extreme temperature changes can affect the performance of electronic components, leading to unexpected behavior or errors in data transmission. However, that's not the only concern. Micrometeoroids, tiny dust particles, or fragments of comets and asteroids that could pose a threat to Voyager 1 are also present. These micrometeoroids, despite their small size, move at high speeds and can cause damage upon impact. Even the slightest collision with a sensitive electronic component could disrupt its functionality or interfere with data transmission. While scientists attempt to decipher the first data transmission from these unidentified objects, Voyager 1 has brought forth one of the most intriguing theories, perhaps indicating that we may have finally made contact with an extraterrestrial civilization. Fortunately, while some may argue otherwise, the discovery of new celestial bodies in our solar system has occurred. However, it begs the question of whether these unidentified objects are more than remnants from distant star systems. What if these unidentified objects point to previously unknown phenomena and undiscovered realities waiting to be explored? The James Webb Space Telescope was created to shed light on events that occurred billions of years ago, when the light from these events finally reached us. In doing so, the JWST discovered massive galaxies born closer to the time of the Big Bang. The telescope uncovered massive galaxies that are 600 million years old or less, too large to have formed through the processes that created other galaxies. We've seen galaxies form quickly, as well as smaller galaxies forming closer to the beginning. These discoveries have forever changed our perspective on the universe and what we consider to be absolute truths. What are your thoughts on these new unidentified objects found in our solar system? Thank you for watching another episode of Space Voyager. Click on the video on your screen for more quality content like this while you're still here.